Dear students, today we will solve the seventh numerical from chapter number 4, whose name is Turning Effect of Force. The numerical states that a 5 Newton ball hanging from a rope is pulled to the right by a horizontal force F. The rope makes an angle of 60 degrees with the ceiling, as shown in the given figure. Determine the magnitude of force F and tension in the string. Dear student, this is the diagram, and we are shown here that this is a ball and its weight is vertically downward, acting vertically downward, and its weight is 5 Newton. I write here its weight is 5 Newton, which is acting vertically downward. We have to find this horizontal component of the force F and this tension in the string T. Before I solve this numerical, I remind you that we have learned in the theory that whenever a force F makes an angle theta with the horizontal, for example, this is a force F and it is making an angle theta with the horizontal, and if we resolve this force, we get its two components. One of the component is along the vertical or the y-axis, and this component is called Fy, and the other component is along the horizontal or along the x-axis, and this component is called Fx. The component which is opposite to theta is called Fy, this component, and the component which is along the direction of the theta is called Fx. Also we know that Fx equals F cos theta and Fy equals F sin theta. I hope that you must be familiar with these two components of the forces. So like here is the situation like this. For example, this is a horizontal and this is the ball. It is tied to the string and the tension in the string is T. Here it is shown, and it is making an angle of 60 degree with the horizontal. So here we will have two components, one of the component along the vertical and other component along the horizontal. The component which is opposite to this angles of 60 degree, it will be equal to Ty, since we are given here the tension as T not F. So in place of F we will write T. So Ty and Ty is equal to T sin theta. And similarly, this horizontal component is represented by Tx, and the Tx is equal to T cos theta. This vertical component Ty or T sin theta is balanced by the weight of the ball, and weight of the ball is 5 Newton, which is acting vertically downward, and the component of this tension in the string Ty or T sin theta is acting in the upward direction. Since the ball is neither moving up nor moving down, it means that these two forces balance each other. So I write here that Ty is equal to weight of the ball, and we know that Ty is equal to T sin theta, and weight of the ball is 5 Newton, so we write here 5. And since we know that the given angle is 60 degree, so sine 60 degree, t sine 60 degree is equal to 5, and sine of 60 degree is 0.866. So to calculate t, we will divide 5 with 0.866, and this will give us 5.77, which is approximately equal to 5.8 Newton. So the tension in the string T, here this force tension in the string T, or here tension in the string T, is equal to 5.8 Newton. To calculate Tx, we will use T cos theta, and this Tx is equal to this force F, but both are opposite in direction. So we can write that this force F will be equal to negative of Tx, and also the Tx is T cos theta. Since we have calculated the value of T, which is this 5.88, I write here 5.8, and multiply it by cos of the angle, which is 60 degree, and cos 60 gives us 0.5. So multiplying 5.8 with 0.8, it will give us 2.9. So the force F, which is acting along the rightward direction, will be equal to negative 2.9, and the tension in the string T, that is equal to 5.8 Newton. Dear students, I again repeat it for the revision. Since when we resolve this force, which is tension, into two components, one component will be Ty, which is equal to T sine theta, and the other component will be Tx, which is equal to T cos theta. So Ty or T sine theta will be equal to weight of the object. I have written here Ty is equal to weight of the object, and Ty is equal to T sine theta, and theta is 60 degree, and weight is 5 Newton. Sine 60 is 0.866 is equal to 5, and dividing 5 by 0.866, we get tension as 5.8 Newton. And the component of the force F, which is acting towards right, will is opposite to the Tx or T cos theta. So F will be equal to negative of Tx, and Tx is T cos theta, and value of T we have calculated, it is 5.8, and multiply it cos of the angle, which is 60 degree, with the horizontal, and cos 60 is 0.5, and multiplying 5.8 with 0.5 will give us 2.9. So the force F will be equal to negative 2.9 Newton, and the tension in the string will be equal to 5.8 Newton. Thank you very much for watching this video. See you next lesson.